Hey everyone, welcome to another LeetCode video. And in this video I'm going to solve the two-sum LeetCode problem, which is a famous problem and it is being asked in technical interviews so many times. So let's solve the problem. So first we need to see what is being asked here. It is being said that given an array of integers nums and an integer target, return indices of the two numbers such that they add up to target. So here we are given an array of numbers or integer numbers and an integer target. We need to find two numbers from the array such that they add up to target. So here we can see that 2 and 7, if we add up 7 and 2, we can get the result 9. So the index of first integer 2, which is 1, and the index of second integer 7, which is 1, we can return 0 and 1 in an array or vector for C++, as we'll be solving the problem in C++. So there are multiple ways to solve the problem, multiple approaches. I'll be showing you both the brute force approach and also the optimal approach. So first let's solve the problem in brute force solution, which we'll be using inner for loop. So first let's take a vector where we'll be storing our result. Now let's first take one for loop and it will be running up to the size. And here we can take the difference between the number that we are pointing to right now and target. Here we can see that the first number that we will be pointing is 2 and our target is 9. So first we can take the difference between 9 and 2, which will be 7, and then we'll be searching for 7 in the rest of the array. So let's take the difference. Int diff equals target minus nums of I. And now the difference will be 7, so we'll be searching for 7 in the rest of the array. So we'll be using another for loop to search for the number. We'll be using j. So j will be equals I plus 1 because first we will be taking the 2 as our current index, and we need to search in the rest of the array. We don't need to search in the first array or first integer or the up to the integer that we are taking right now. So that's why we will be searching in the rest of the array. So the value of j will be I plus 1. So j is smaller than nums dot size, and it will run up to nums dot size obviously. And we will be searching for if the difference that we are searching for is equals to the number that we are pointing to right now in the inner loop. If it is the case, then we'll be pushing the result. We'll be adding the result in our result vector. Push back. It will be nums of I. Sorry, not nums of I. We need to return only the index of the array. So it will be I for first one, and result dot push back j for the second one. And after that, we can return the result. So we need to also type it here because it will only run if the if statement runs, and hence the compiler will not let us run the solution without a return statement. That's why we are giving here return result, because there's obviously will be one solution and only one solution will be there, because it is being said that you may assume that each input would have exactly one solution and you may not use the same element twice. So that's why it is not required, but we need to give it here. So let's run the problem and see if it is accepted or not. So yeah, it is accepted. If we submit it, I guess it will be accepted. So yeah, as also it is taking order of n square time complexity, but it is being accepted. It is not giving us any time limit TL error or time limit exit error. So we can optimize it using map. So I'll be now solving this using